everyone, welcome back to my channel. So this video we are continuing the exercise number 6.3 from chapter 6 triangles. If you are new to the channel, please don't forget to subscribe. So let's start. Second question from exercise number 6.3. In below figure, triangle ODC similar to triangle OBA, angle BOC equals to 125 degree, angle CDO equals to 70 degree. Find angle DOC. Find angle DOC, angle DCO and angle OAB. So in this below given figure, triangle ODC, this triangle and triangle OBA, both are similar triangles, and we have given the measurement of angle BOC which is 125 degree and angle CDO which is 70 degree. So find angle DOC, angle DCO and angle OAB. So here we can see from this figure, DOB is a straight line, right? DOB is a straight line, right? So if any angle formed on a straight line, the sum of an angles formed on a straight line is equals to 180 degree. So here we already know this angle. So here we can say this is a straight line. So the angles formed on this will be, the total will be 180 degree. Linear pair. So here this is 125. So we can easily find out the angle O. So that is angle COB plus angle DOC equals to 180 degree. Angle COB which is given, that is 125 degree plus angle DOC equals to 180 degree. Angle DOC equals to 180 degree minus 125 degree which is equals to 55 degree. Okay. So angle DOC equals to 55 degree. Now we find the angle DOC which is this angle which is equals to 55 degree. The second angle we need to find is angle DCO which is this. So we know the sum of the three angles of a triangle is equals to 180 degree. So we already know the two angles, so it is easy to find the third angle. So in this triangle, triangle ODC, angle D equals to 70 degree, angle O equals to 55 degree. We need to find angle C. So that is angle D plus angle O plus angle C equals to 180 degree. The sum of the angles of a triangle. So which is 70 degree plus 55 degree plus angle C equals to 180 degree. Angle C equals to 180 degree minus 70 degree plus 55, so that is 125 degree. Angle C equals to 55 degree. Angle C which is angle DCO. So angle C which is angle DCO equals to 55 degree. So we find the second one also. The third one is angle OAB. We need to find the angle OAB, this angle. We have given triangle ODC. Triangle ODC is similar to triangle OBA. So if two triangles are similar, their corresponding angles are always equal. So we already know we need to find OAB. So which is the corresponding angle of this angles in the other triangle. So that is OBA, OAB. The corresponding angle is DCO. So that is angle DCO will be equals to angle OAB. Why? Because the corresponding angles of two similar triangles are always equal. So we already know angle DCO equals to 55 degree. So angle OAB will be also equals to 55 degree. Angle OAB equals to 55 degree. Let's see the next question. Question number 3. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at the point O. Using a similarity criterion for two triangles, show that AO by OC is equals to OB by OD. So first let's construct the figure. Let's draw a trapezium ABCD. So in a trapezium, one of the opposite sides will be in parallel. So let's join this ABCD. ABCD is a trapezium. So that is A, B, C and D. And given AB is parallel to DC. And we need to draw the diagonals AC and BD of this trapezium is intersecting at the point O. So let's draw the diagonal AC and BD. So these two diagonals are intersecting at point O. So this is O. Using a similarity criterion for two triangles, show that AO by OC is equals to OB by OD. AO by OC is OB by OD. Let's mark that. We need to prove AO and upon OC is equals to OB, which is this one, OB by OD. Right? We need to prove AO by OC is equals to OB by OD. So for that, first let's consider two triangles. Triangle AOB and triangle DOC. So to prove AO by OC, that is AO by OC and OB by OD, right? So we can consider these two triangles. If we prove the similarity criterion of these two triangles, then the corresponding sides of this triangle will be in proportion. So now let's prove these two triangles are similar triangles. So in triangle AOB and triangle DOC, let's mark the angles. Angle 1, angle 2, angle 3, right? And this angle will be angle 4. This one is angle 5 and angle 6. This is angle 6. So if two parallel lines, if a line is drawn intersecting two parallel lines, the alternate interior angles will be always equal. So here angle 1 is equals to angle 5 because these are alternate interior angles, and angle 2 is equals to angle 4. So in triangle AOB and triangle DOC, angle 1 is equals to angle 5. Similarly, angle 2 is equals to angle 4 by using alternate interior angle. Because AC and BD are a transverse drawn through two parallel lines. So the alternate interior angles are always equal. So which is angle 1 is equals to angle 5 and angle 2 is equals to angle 4. Angle 1 here is angle A is equals to angle 5, which is angle C. And angle 2, which is angle B, is equals to angle D. So in triangle AOB and triangle DOC, we already proved two of the angles are equal. So by similarity angle similarity rule, we can say triangle AOB is similar to triangle DOC. We know if two angles are equals for two triangles, the third angle will also be equals. Otherwise, we can also say angle 3 and angle 6, the opposite vertex angles are always equal. So angle 3, which is angle AO, and it is equals to angle O. Angle AOB is equals to angle DOC. So that is by, we can say it is always by AA similarity or by AAA similarity rule. So if two triangles are similar, their corresponding sides will be always in proportion. So we have to prove that AO by OC is equals to OB by OD, right? So if these two triangles are equal, their corresponding, the proportion of their corresponding sides will be always in proportion. So that is, hence this is proved. Hence this is proved. AO by OC, which is AO by OC, will be equals to, because AO is the corresponding side of AO is OC and the corresponding side of OB is OD. So if two triangles are similar, we proved that these two triangles are similar by AAA similarity rule. So their corresponding sides will be always in proportion. So let's move to the next question. The fourth question, in the below given figure, QR by QS is equals to QT by PR and angle 1 is equals to angle 2. Show that triangle PQS is similar to triangle TQR. So the given figure, we need to prove triangle PQS. Let's draw that triangle outside here. Triangle PQS. PQS is similar to triangle TQR. TQR is the biggest triangle. Big triangle than the other one. So triangle TQR. And we have given QR by QS is equals to QT by PR. So given QR by QS is equals to QT by PR. You already given QR by QS is equals to QT by PR. Let's mark that side. So that is QR, which is this side of the bigger triangle, triangle TQR. QR is in equals by QS. So this is the corresponding side by QT. QT by here we have given PR, but the side of this triangle is PQ. So let's see triangle PQS. Let's see the triangle PQR. Sorry, triangle PQR. Let's draw that here. Triangle PQR. We know PQR. So this is angle 1 and angle 2, and given angle 1 and angle 2 are equal. So angle Q is equals to angle R. So the opposite sides of the equal angles are always equal. The side opposite to the equal angles are always equal. So the side opposite to Q is PR. So that is PR. It will be equals to the side opposite to angle R is PQ. PR will be equals to PQ. So that's the first equation. So from this we can write QR by QS is equals to QT by PQ. We already proved that PQ is equals to PR. So PR we can write it as PQ. This is from the first equation. Now we have proved two sides of this triangles are in proportion. So that is PQ, QR by QS, QR by QS is equals to QT by PQ. So this we proved, and we already know one of the triangles, which is Q. This is equal in both the triangle. Triangle Q is equal in the other triangle. So by side angle side similarity rule, we can say triangle PQS is similar to triangle TQR. Correct? So by side angle side, we proved that triangle PQS is similar to triangle TQR. So let's continue this exercise in next video. If you are new to the channel, please don't forget to subscribe. Thank you for watching.